You buy access to one of the most capable AI models on the planet. It can write code and pass the bar exam, but the moment you ask it a question about your internal HR policies or last quarter's revenue, it fails. When a model comes up empty on these internal tasks, the typical reaction is to assume the model itself needs to be rebuilt or customized. Acting on that assumption leads to massive investments in cloud compute and specialized engineering, often before the actual problem is understood. Before committing capital to infrastructure, a team has to determine why the model is failing. Is it a lack of data or a lack of ability? Mistaking a lack of information for a lack of intelligence leads to expensive training cycles that don't actually solve the underlying data gap. This starts with the strategic matrix. First, a knowledge deficit, lacking access to specific facts. The solution is RAG, attaching an external library. Second, a behavior deficit, struggling with specific formatting or tone. The solution is fine-tuning, reshaping the model's internal weights. The distinction is simple. RAG updates what the model knows. Fine-tuning updates how the model acts. RAG is the most direct way to integrate private data. It's like giving a consultant an open-book library of your rulebooks right before they take an exam. This chart shows the process. When a user asks a question, the system searches a vector database, pulls relevant document chunks, and feeds them into the AI's context window to generate an answer grounded in those facts. Because the model is instructed to answer using only the provided text, the frequency of invented facts drops significantly. The system can even point to the specific document and section it used for the answer. This allows for real-time updates. If your pricing changes today, you just update the files in the database, and the AI will use the new data on its very next query. Fine-tuning, however, doesn't use an external database. It involves a secondary training cycle that alters the model's internal configuration. It's more like a residency program. Through repetitive practice on thousands of examples, the model develops new reflexes for specific types of work. This is the choice when you need to ensure consistent JSON formatting for software integrations, or when you need to replicate a highly specific brand voice that is difficult to describe in a prompt. Because these behaviors are baked into the model, you no longer need to include long instructions in every prompt. This reduces the number of tokens used per request and increases processing speed. Essentially, choose RAG for data agility and auditability. Choose fine-tuning for consistent structure and lower latency. Standard RAG has a limitation. It relies on keyword or vector similarity. It struggles when a query requires connecting information hidden across multiple, unlinked documents. To solve for this, organizations are adopting GraphRAG, which maps the relationships between data points before the search begins. As this diagram illustrates, standard RAG sees data as isolated points. GraphRAG identifies entities, like people, accounts, or companies, and maps the connections between them. By building this web of relationships first, the AI can trace how these entities interact across your entire multi-year document history. Standard RAG is perfect for lookup tasks, like retrieving a specific revenue figure from a single report. GraphRAG is designed for high-level reasoning. It can identify thematic vulnerabilities in a supply chain by connecting data points that sit in separate files created years apart. While it requires more effort to set up than standard RAG, it enables the model to perform global summarization and complex relational discovery. To see how these architectures work in practice, let's look at 3 common enterprise bottlenecks. The first is a portfolio tracker, providing live global asset prices, which change every microsecond. For this, we use standard RAG. Fine-tuning is impossible because the weights would be outdated before training finishes. We simply connect the AI to a live data feed. The second is a legal tool that must take notes and output contracts that follow a strict, non-negotiable formatting style. Here, we use fine-tuning. By training a smaller model on thousands of gold standard contracts, the specific layout and tone become the model's default response pattern. The third is a forensic audit, looking for patterns across 5 years of emails and chats. This requires GraphRAG. The system links a specific calendar meeting to a conversational hint 3 weeks later, tracing the relationship between those events. Success in these deployments comes from matching the specific friction point of your business to the correct architectural strength. The question isn't which AI model is the smartest. It's whether your project requires an open library, a trained reflex, or a relational map.